Welcome. We're going to be doing a 1.3 extension lesson on absolute value equations. So if you're looking for the textbook section that's about this lesson, it's actually from the Algebra 1 textbook that you have on Big Ideas, and it's the 1.3 extension. So we're going to learn how to solve equations that have absolute value in it. So to solve the absolute value of ax plus b equals c for any c greater than or equal to 0, you're going to solve two related linear equations. One where you take what's in the absolute value signs and just set it equal to c, and the other when you take the absolute value sign and set it equal to negative c. Now let's just do an example, just a simple example to kind of see why we do this. So what if I just have this simple absolute value equation, the absolute value of x equals 6. Well, what's x? Well, what two numbers are equal to, or what two numbers have an absolute value of 6? That would be 6 and negative 6. So, right, this thing in the absolute value is either 6 or the negative version of that, because the absolute value of negative 6 is 6. That's exactly what they do in this problem, right? That whole thing, the absolute value, is either positive c or it's negative c. Now, before we continue, the next thing we'll talk about is this. Why does it say for c greater than or equal to 0? Well, we're going to find out. Again, let's set up another simple equation. So what about if the absolute value of c is equal to negative 3? Well, what numbers have an absolute value of negative 3? No numbers do, right? Because no numbers can be 3 or negative 3 away from 0. That's our definition of absolute value, the distance away from 0. So if you ever get an absolute value equation with an answer, or an absolute value equation where one side is equal to 0, right? The absolute value of something is equal to 0. Your answer is automatically going to be no solutions. You don't even need to work to solve it. Let's try some out. So example 1, solve absolute value of x minus 4 equals 6. Graph the solutions. We'll talk about the graphing in one moment. Let's just focus on the absolute value of x minus 4. What I do now is I like to think, okay, I got to break that x minus 4 out of prison, right? It's still absolute value of prison bars. How I'm going to do it is it's going to split it into 2. So on the left, that's going to turn into x minus 4. So I'm just taking what's inside the absolute value signs. I get rid of the absolute value signs, take what's in it, and set it equal to positive this number, or just that original number. And then my right equation is going to be that same thing inside the absolute value, and I'm going to set that equal to negative of this, right? Or I could think of it as the opposite of that. Okay, now we just have to solve these equations. Well, these are simple one-step equations. Well, x minus 4 equals 6. How do I get x by itself? Well, I get rid of the 4. It's minus 4, so I add 4 to both sides, and I'm left with x equals 10. That's one solution. My other solution, let's see, x minus 4 equals negative 6. Going to make my t-chart. Well, what's in the way of x being by itself? It's 4. Since it's a minus 4, I add 4 to both sides. So I'm left with x equals, well, negative 6 plus 4 is negative 2. Just be really careful with your integer addition here. Now the last thing, it says graph solutions. That's a fancy way of saying make a number line and plot the solutions on a number line. So again, I'm going to make a number line. Let's see, I'm going to put 0 right here, a little offset, and let's see, as I go to the right, I'm going to count up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then as I go to the left, negative 1, negative 2, negative 3, negative 4, and then let's see, I'm going to graph my solutions. 10 is right here, negative 2 is right here, and there we go. Next, I'm going to solve absolute value of 3x plus 1 equals negative 5. Well, so first step in any absolute value equation is I'm going to check what's over here, right? Once I have an absolute value equals something, I'm going to check the right side. Well, that's negative 5. So what am I going to do? I'm going to write no solutions because I can never have the absolute value of something be negative. And that's all I have to do. I'm done. I notice the absolute value is equal to a negative number, automatically means no solutions. Let's do another example. So solve 3x plus 9, absolute value of 3x plus 9, minus 10 equals negative 4. Now, this requires one more step before you break 3x plus 9 out of jail. So, you cannot break out the absolute values until it's just the absolute value on one side of the equation. So it can only be the absolute value on one side of the equation, and then I can break it apart. So first, I'm just going to work to get the absolute value alone on the left side. Well, what's in the way of the absolute value being alone? It's this minus 10. So I'm just going to make a little mini t-chart because I kind of can see into the future, and I know that I'm going to have to break 3x plus 9 free in a moment. So I'm just going to make a mini one, and when I add, it's a minus 10, so I need to add 10 to both sides to get rid of the minus 10. When I do that, I'm left with just the absolute value of 3x plus 9 on the left, and well, negative 4 plus 10 is 6. Now, this is a really good point. If you look at this problem, you might have noticed that right now this was equal to a negative number, but you don't want to jump to the conclusion that it's no solutions just yet. You can only do that if there's just the absolute value on the one side of the equation. If its absolute value equals a negative. But if there's an absolute value plus or minus or times or divided by anything else, you got to make sure to solve for the absolute value, so it's just the absolute value on that side, and then you can evaluate if there's no solutions or if you need to solve for some solutions. Whoops, I did not mean to erase that whole line. There's the line. Now, since it's an absolute value equals, I can break 3x plus 9 free from its prison cell and write this as 3x plus 9 equals, well, 6. And 3x plus 9 equals a negative 6. One thing you want to be very careful with on these equations is make sure when you rewrite the two equations, you got rid of the absolute value signs. Some people like to still keep them when they do this. But when you split it into two, the absolute value signs disappear. 3x plus 9 broke out of its prison. So now I'm just going to solve these two-step equations. Well, 3x plus 9 equals 6. The things in the way are 3 and 9. 3 is my best friend, so I'm going to get rid of the 9 first. And how do I do that? I subtract 9 because it's adding 9. So I'm left with 3x equals, well, 6 plus minus 9 is negative 3. Then what do I need to do? It's a 3 times x. So I'm going to divide by 3 on both sides. And I'm left with x equals, well, negative 3 divided by 3 is negative 1. Now let's do my right-hand equation. 3x plus 9 equals negative 6. If you notice, solving this equation is very similar to the steps in solving the left equation. I just have a different thing on the right side. So again, just like the other one, I have to get rid of that plus 9, so I'm going to subtract 9. So I'm left with 3x equals, well, negative 6 minus 9 is a negative 15. And then to get rid of the 3 times x, I'm going to divide by 3. So I'm left with just an x equals negative 5. And those are my two solutions. X equals negative 1 and x equals negative 5. We're going to end things off with a word problem. So the average number of seeds in a package of cucumber seed is 25. The number of seeds in the package can vary by 3. What are the maximum and minimum number of seeds that could be in a package? Well, let's underline our problem. That is, what are the maximum number and minimum number of seeds that could be in a package? So when a problem is asking for maximum and minimum numbers, it's kind of a hint that it's going to be solved with absolute value equations. That's kind of the one big use for absolute value equations, is to find a maximum or minimum, because it can help us find both numbers with one simple equation. What kind of key information do I have? Well, let's see, the average number of cucumber seed is 25, and it can vary by 3. So essentially, let's find a variable for what our cucumber seed can be. So we're going to say C is the number of cucumber seeds in a package. We know that the average is 25 and it can vary by 3, meaning the difference between the seeds in our cucumber packet C and the average number of 25, so difference of C and 25 is equal to 3. Let's turn this into an equation, and this is where absolute value comes in handy. A lot of times what we do is to write the difference between two numbers, we write it as the absolute value of C minus 25, and I'm going to let you know why we do this. So normally, if I told you find the difference between 26 and 25, you would do 26 minus 25, right? And that's 1. You wouldn't do 25 minus 26 because that equals -1. So remember, if you're finding the difference between, you're just going to find how many away they are from the other. So we use absolute value. And another reason why we do that is we don't know if C is greater than or less than 25. So usually when they tell you to find the difference, you do the higher number minus the lower number. But in this case, we don't know if C is higher or C is lower. So we take the absolute value, because then we're going to get out a positive difference. So we know their difference, absolute value of C minus 25, is equal to 3. Now I have an absolute value equation I can solve. I am going to break this into 2 equations to break C minus 25 out of jail. So I'm left with C minus 25 equals 3, and C minus 25 equals -3. Make my t-chart. To solve for C on my left equation, I want to get rid of the minus 25, so what am I going to do? Add 25. So I'm left with C equals 3 plus 25 is 28. And on my right, I'm going to make my t-chart. How do I get rid of that minus 25? Again, I'm going to add 25 to both sides. So on my left, I'm left with C. On my right, well, -3 plus 25 is 22. So let's go and answer my equation. So the minimum number of seeds is 22, and the maximum number of seeds is 28. Thank you so much for watching this video.